Yes, students, this particular class I am going to discuss about geometrical properties of a parabola, and then I am going to discuss about the reflection property of a parabola. See, this is the parabola, let us say the standard parabola. At a point P, you know that point is a t square comma 2at. At a point P, a tangent is drawn to the parabola. You know the equation of the tangent. The equation of the tangent is yt is equals to x plus at square. X plus at square. That is the equation of the tangent drawn at a point P. Okay. So that tangent meets the axis of the parabola at a point T. I hope so everyone know what is a focal distance. You know about SP. SP is nothing but PM. What is PM? From a point P onto the directrix, a line is drawn perpendicularly. So that is say PM. Right? So SP is equals to focal distance, that is nothing but x1 plus a. Here that is nothing but a plus at square is the focal distance. That is same as PM. But you got the information. This is the equation of the tangent meets the axis. So that's why we can say the easily the coordinates of t. On x-axis, y coordinate is equal to 0. But what about the x coordinate? In the tangent equation, put y is equal to 0. You will get x is equal to minus at square. So that's why this point we got minus at square comma 0. At the same time, I hope so you can say the coordinates of M also, because this is a directrix. When this is a directrix, this particular a point x coordinate is always minus a, and this is at square comma 2at. It's perpendicularly drawn here. That's why y coordinate is nothing but 2at. So now you can check here. What about MT? Just I am finding MT. Observe here. That means the distance between M and T. The distance between M and T. If you observe, S point is a comma 0. We got SP is equal to a plus at square. Find out the distance between these two points. No need to find out. If you observe these 2 points, observe these 2 points. Distance is same. That's why MT, right? So ST, this distance is A because this is the vertex of the parabola, and this distance is equal to at square. This length is equal to at square. This length is equal to at square. That's why ST is also equal to a plus at square. That is the same as MT, right? So what the information we got? SP length is the same as PM length is the same as MT length is the same as ST we got. That means all the sides are equal, so it is a rhombus. At the same time, immediately you know rhombus diagonals bisect each other perpendicularly. Okay, this is the one of the diagonal. Whether you observed or not, P, T, middle point, P point, T point, middle point must lie on tangent at vertex. That is nothing but on y-axis. Because here x coordinate is at square, here x coordinate is minus at square, middle point we are getting 0. That's why this point is Q. No doubt the other diagonal also passes through the same point Q. So we got the information now. This angle is equals to 90 degrees. Why? Because we have got the information PMTS. Sorry, SPTM. SPTM is a rhombus. That information we have. We know diagonals perpendicularly bisect in rhombus. So that is the reason the point of intersection of diagonals is Q. At the same time, they are intersecting at 90 degrees. So another point you can see, a line perpendicular to the tangent at the same point P, that is called normal. So that is the normal. You know the equation of normal. The equation of normal is y plus xt is equals to 2at plus at cube. That is the equation of the normal. Normal meets the axis of the parabola at a point n. Now can you say, no doubt this point y coordinate is 0. If you put y is equal to 0, then you will get t gets cancelled. We are getting x coordinate as 2a plus a t square. So that is about n point we got. If you observe carefully, the length Sn is nothing but a plus at square. The length Sn is nothing but a plus at square. The distance between these 2 points is a plus at square, and st also a plus at square, right? Sn, st are equal. If you observe the triangle PTN triangle, for the triangle PTN, SP is nothing but median. That is the one more information we got. Okay, right. So PMTS is a rhombus. Rhombus diagonals intersecting at a point Q. That point Q lie on y-axis. That is nothing but tangent at vertex. You can see the first point here. From focus onto the tangent, because it is a P is a point on the parabola. Not only at the point P, anywhere you can draw a tangent. From focus onto any tangent. This is foot of the perpendicular or not? Q is the foot of the perpendicular. From focus onto any tangent, this is the foot of the perpendicular. Where this foot of the perpendicular lie? Foot of the perpendicular lie on y-axis. What is y-axis here? Y-axis is the tangent at vertex. So what we can say? The locus of foot of the perpendicular from focus onto any tangent of the parabola lie on tangent at vertex. See, from focus onto this tangent, Q is the foot of the perpendicular. Q lies on y-axis. Y-axis is nothing but for this parabola at the vertex tangent, right? So that is a very, very important point. At the same time, we got the information here. So P at a point P, tangent is drawn, and now this is the portion of the tangent between the directrix and the point of contact. This is the portion of the tangent between the point of contact and the directrix. That is nothing but PL. Can you say what about the coordinates of L? Easily we can say the coordinates of L. L point x coordinate is minus A. Yes, L point x coordinate is minus A. If minus A substitute here, you will get the y coordinate as a t square minus a divided by t. So that is about L coordinates. If you find out the slope of SL and SP, SL slope and SP slope product, you will get -1. That means the portion of the tangent between the point of contact and the directrix, that is nothing but PL. That PL subtends 90 degrees at focus. The portion of the tangent between the point of contact and directrix, this is the portion of the tangent between the point of contact and directrix, subtends 90 degrees at focus. So that is one more important observation you can see here. So another information you can observe, ST is the same as SP is the same as SN. Agree or not? ST is the same as SP is the same as SN. Okay, ST is the same as, this is ST is the same as SP. Then what we can say, this triangle is an isosceles triangle because this side and this side are same. So that's why if this angle I am taking it as a theta, then no doubt this angle is also theta. But now you can observe these two lines are parallel lines. It's a transversal. This angle theta means no doubt this angle is also theta. Whether you observe or not, angle SPM. Observe angle SPM. For the angle SPM, tangent is the internal angle bisector. Tangent is the internal angle bisector. Whenever tangent is the internal angle bisector means what about the normal? Because angle between angle bisectors is always 90 degrees. Angle between angle bisectors is always 90 degrees means this is a tangent, this is a normal. Automatically we can say normal is the external angle bisector of SPM. This is the external angle bisector of SPM and tangent is the internal angle bisector. Then we can come to a conclusion. That conclusion is like this. You can observe this is a line and this is a normal to that line. This is a ray of light incident on this and its reflection. Angle of incident is the same as angle of reflection or not. So that's why a ray of light traveling along a line, parallel to the axis of the parabola, a ray of light traveling along a line parallel to the axis of the parabola gets reflected. That reflected ray must passes through the focus of the parabola. That is the reflection property of parabola. That is the reason we got tangent is an internal angle bisector, normal is the external angle bisector. Once again, a ray of light traveling along a line parallel to the axis of the parabola gets reflected and the reflected ray must passes through focus of the parabola. So that is the reflection property of the parabola. One more point you can see here, whether you observed or not, the triangle. So the triangle PSL is a right angled triangle. For the triangle PSL is a right angled triangle. For that right angled triangle, this is an altitude or not? For the right angle triangle PSL, SQ is an altitude, right? So these are the few points on the parabola and its applications. One more point I want to discuss here. You can observe SP. Now I am constructing a circle with SP. We will call SP as the focal radii. Actually we are calling it as a focal distance. You can say this one as focal radii. SP as a diameter. SP as a diameter. If you construct a circle, you see the reason is this portion of SP subtends a 90 degrees at a point Q. That's why if SP as a diameter, if you construct a circle, that circle touches the tangent at vertex at a point Q. So this is the circle. That circle is, for that circle, this is the circle with SP as a diameter touches the tangent at vertex at a point Q. What is Q? Q is foot of the perpendicular from focus onto the tangent, right? See, one more question I will discuss here. The question goes like this. A ray of light travels along a line. Let us say this is the parabola. Y square is equals to 4ax parabola. A ray of light travels along a line y is equal to 3 and meets the parabola y square is equal to 9x. Y square is equal to 9x means, can you say what about the focus for this parabola? For this parabola the focus is 9 by 4 comma 0, right? So now here y is equal to 3 means y coordinate is equals to 3. Substitute here, you will get x coordinate is equals to 1. So a ray of light travels along this line, gets reflected. That reflected ray must passes through focus. That is the information we have. But how to find out the equation of the reflected ray? Yes, we can find out the equation of reflected ray. The reason is that reflected ray must passes through the focus. You know this particular point as 1 comma 3 and you know this point as 9 by 4 comma 0. So automatically we can find out the equation of a reflected ray. So another question here, there is a parabola given. The parabola equation is given as y minus 3 whole square is equals to 4 into x minus 7. That is the equation of a parabola. A ray of light travels along a line y is equal to 5. This is the ray of a light travels along the line y is equals to 5. Now if you substitute y is equals to 5 here, y is equals to 5, then you will get x coordinate as 7. That means this point is 7 comma 5. Because y is equals to 5, 2 square, 4 cancel. Sorry, x coordinate you will get 8. Right? Now, what is the focus for this parabola? Vertex of the parabola is 7 comma 3. A value is equals to 1. That's why 1 comma 0 we have to add. Vertex of the parabola is 7 comma 3 plus, because when the parabola is in the form of y square is equal to 4x, focus is 1 comma 0. But for this parabola the vertex is 0 comma 0, but here the vertex is 7 comma 3. So we got the information 8 comma 3 is the focus for that parabola. Whether you observed or not, that focus is exactly below that one only. This is the focus. The reason is here also x coordinate is 8, here also x coordinate is 8. So that's why focus is 8 comma 3. That is the information we got. Now can you tell me what is the equation of the reflected ray? The equation of the reflected ray is nothing but x is equals to 8 line. But he is not asking the equation of the reflected ray. The equation of the second reflected ray. That means what happens? Again it reaches like this, meets the parabola at a point. Come on, can anyone say what about this point? 8 comma, you see 5 to 3. That means this distance is 2 units. Again this distance is also 2 units. That's why 2 units we have to decrease. 5, 3, next this point becomes 1. Now the reflected ray, the second time reflected ray, because a ray incident on here, this is the first reflected ray passing through the focus. That line equation is no doubt x is equals to 8. Now this is the second reflected ray. This is the second reflected ray. The equation of this second reflected ray is y is equals to 1, because we got the y coordinate is equals to 1. So these are the few properties, geometrical properties of a parabola and reflection property of a parabola. Next class I will try to discuss few more questions. Okay, bye bye, see you.